Hi everyone. My slides are all orange. I did not wear an orange t-shirt on purpose to match this. Complete coincidence. Hopefully I don't merge into the background. Okay, so yeah, as Lee says, I'm going to be talking about progressive web apps. But in particular, I'm going to talk about offline development and how that kind of relates to progressive web apps. So most of you know who I am already, as Lee says, but so my name's Mike. I am the lead trainer at Maiden Academy. We're based here. We train software developers, either new aspiring software devs or existing ones in CPD style stuff. My background is in full stack, LAMP and Node. My job now is basically I learn stuff and then I tell it to other people. It's kind of why I'm here. So what is a progressive web app? Some guy on the internet says that progressive web apps are experiences that combine the best of the web and the best of apps or native apps. So we're going to spend the next, I don't know, half an hour, 45 minutes talking about what that means. If the clicker works. Okay, so what is it? Well, the PWA as a term was coined by Alex Russell in 2015. He's or was a Google developer. The idea is they appear to your users as if they're a native application on your mobile device or even on your desktop. They can work offline, just like a native app can. They don't have to, but it's one of the available features. And the idea is that they're operating system agnostic. So at the moment, if you're building mobile apps, you have to write one in Java and one in Swift, or you have to run it through like a SDK to get native versions out. Yes?
Are they working on Linux?
Sorry?
Are they working on Linux?
I looked and I couldn't find anything about it. So as far as I know, no is the answer. I mean, yes, it will technically still run, and we'll kind of get into why, but you don't get all of the same features that you do in these operating systems. Okay? So this is Windows and Windows Mobile. Android, obviously, iOS only recently, but so the latest iPhone it will work on, and OS X, which is pretty cool. So a progressive web app is actually just your application, the one that you've already got now that works via your web browser, just with a bit more JavaScript. So there's not really actually a massive amount to do. I'm going to take you through the code of how you convert what you've got now into a PWA, but it's basically just your application already, but pretending to be a native mobile app. The kind of the big benefit of this is it means there's no more App Store needed. It's probably not going to result in the end of the App Store, but it means that you don't actually have to put your application into the App Store. People can just go to your website, go to your application, start using it, and it will just install in the background for them rather. So the idea is that it's your users will use your application to install it rather than install it to use it, which is a much nicer user experience. They don't have to bother going and installing any of these big things via the App Store. It just kind of cuts out the middleman. There are some gotchas, I suppose, with it, and that is that they don't just automatically straight away install as soon as somebody visits your site. Otherwise, you'd end up with thousands of applications on your mobile phone. So what Google kind of had decided is that the install will trigger if a user visits your application at least twice with at least 5 minutes in between. Okay? Now, let's have a look at what it looks like when it installs. This GIF is reasonably quickly, so I'll let you watch it a few times because it goes quite fast, but I've got a GIF of what actually happens. So you go to your application, Google something, click the link, go into your online application, and once it's loaded, you get this little pop-up, add to home screen, which then when we go back to the home screen, makes a little icon appear, click the icon, and it opens exactly the same application you were in before, but this time it's working full screen as if it's a native application. I'll let you watch that one more time. Yeah, makes sense? Okay, so why would we want to use PWA? I've got a couple of case studies. There's loads of these online, but I'm going to go through a couple of them about some of the benefits of what you get from doing progressive web apps. So Tinder were one of the first sort of major native apps to go PWA. When they did it, they found they cut their average load time from 11.9 seconds down to 4.6, which is a reasonable performance increase, I would say. And their new PWA is actually 90% smaller than the native Android app.
Is that versus just a web page?
It's versus their native application.
So it's faster versus their native?
Yeah. Uber have also created a PWA. Theirs is only 50 kilobytes when gzipped, so it downloads extremely quickly. They designed it so that if you're stumbling around drunk in the middle of a field and you've only got 2G, that you can still load the application in less than 3 seconds, which is pretty good, particularly when you're drunk. Trivago, they've also got one. So less on the performance side here, we've got some stats about business. So they saw 150% user engagement increase over versus their native application, which resulted in 97% increase in the hotel offer clicks. And actually it meant that 67% of their users kept browsing when they were offline versus obviously what used to happen on their website, which you can't browse when you're offline. Oh, sorry, too far. Okay, last one, Pinterest. So they've gone PWA 2. Their user engagements increased by about 60%, which meant that there was a 44% increase in user-generated revenue, ad revenue. It's not a bad thing. And actually the time spent on the site has increased by 40%. These kind of stats come from the fact that now as soon as people visit Pinterest or once or twice, the little pop-up will come, they can click it, and it immediately installs. They don't have to bother going via the App Store to install stuff, so it's a lot more seamless user journey. People are a lot more willing to install these things. They don't take a long time. There's no massive 50 meg, 60 meg download. As you saw earlier, these things are tiny. It's just JavaScript. Okay, so let's talk about how we make your application a PWA. You need 3 things. HTTPS, but you're already doing that, so I'm not going to talk about that. You need a web app manifest file, which we're going to look at in a minute. It's basically the settings for your application. Tells the device how to render the app when it's acting like a PWA. You need a service worker, which is a bit like a client-side proxy. So we're going to talk about that quite a lot. Technically, once you've got those 3 things, you're done, and you've actually got a working PWA. But you probably want to make the most out of the service worker, so you need some stuff from the web API too. That's not actually mandatory, but you're going to want to use it, and we'll talk about that more in a minute. So what's a web app manifest? It's just a JSON file that you just chuck into your application. That's really annoying that it's cut my slide off. So the manifest file, as I say, it's just a JSON file, and basically it's just the settings for your application. So you specify the language. The background color is not the background color of what it will render at. It's the background color of the loading screen, the splash screen as you open the application. Start URL. So that's when they click the icon from your home screen, which page you want them to see first. Maybe it's not your index page. It could be something else. Description is literally just like metadata, really. Display, this is the important one, so that you've got a couple of options, but the one that you want, the one that's the only one you want really, is standalone. This is what tells the device to treat the application as if it were separate from the browser. So you can put browser in there, and then when they click the home icon, when they click the icon on your home screen, it will just open in the browser. That's just a bookmark by that point. So actually, standalone is what you want, and then it looks like in the device it's a separate application. You've got icons, which is an array of image objects, basically. This is you have to put in a couple of different image sizes depending on the devices. You also want to put in an image size for the splash screen because it loads an icon in the middle of the splash screen as it's opening the application. Depending on the size of the application, that will disappear pretty quickly. And then finally, specify your orientation, so which way you want it to open in the application by default. Yes?
So in your example, the animated GIF, did it not just put a Chrome
as the image.
Yeah, so if you don't put any icons, it will just use the Chrome or the Firefox or whatever icon. That just means that that example didn't specify. Okay. Hang on, let me just. Yeah, cool. Okay, fine. Right, so that's your. Oh no, I haven't done that. Sorry, I missed this bit. So that's your manifest JSON file. In order to then, once you've created the file, to put it into your HTML, I apologize that this is cut off. You literally just need a link tag in the head of your HTML, which has a rel of manifest and an href of where your manifest JSON file is. That's it. It's as simple as that. So we've got HTTPS, we've got our manifest JSON file. Now we want a service worker. So service workers, as I mentioned earlier, are client-side proxies. Bit of information about them. So they run in a separate execution thread to JavaScript. So they're not going to interfere with what your client JavaScript is doing, which is beneficial. But it does mean that they've got no DOM access, so you can't put stuff straight into the DOM from in your service worker. There is a way of getting stuff back into your client JavaScript using this new API called post message. It's quite complicated, it's fairly new, and it's not completely supported across all the devices yet. But it's getting there, and it does mean that you can start to communicate between your service worker and your client JavaScript, which will be really, really good, really powerful. So they can interact with all network requests. So any kind of AJAX request, any request basically going out of your application, your service worker can pick up and it can do something with that, which is where the power of PWA really comes from. They're often used for cache management. That's kind of the most common feature of service workers, but we're going to look at some of the slightly more advanced stuff, as well as cache management. So in order to create a service worker, you need this bit of code. Chuck this in the head of your document. All it does is we start off by checking if service workers are supported in the current browser. If they are, then we register your service worker file. So this is just another JavaScript file, and we're going to go into what goes in there in a minute. Specify the scope, so that's sort of where in your application this service worker has access to, what it applies to. So you can just say, right, this folder, for example, it can only handle requests coming out of that folder. I've just given it root access just everywhere. Then all I've done is just, it returns a promise, so I've just done a then and done console.logged out that it worked, or caught the fact that it failed and just said no, and then with an else just saying, actually, this browser doesn't support it. Yes?
They're using Chrome as an engine for rendering of the application, isn't it? Can it work standalone without Chrome browser?
So it's actually using the browser behind, but sort of when it's opened, it just basically fakes that it's not. So yeah, it's using the Chrome engine underneath, or the Firefox engine, or Safari now behind the scenes, but it just pretends like it's not effectively. Yeah?
And the same application is running on Windows and can be run on OS X as well?
Yes. Yeah, so you can actually make it look like a native program on your computer. It's a little bit harder to do that than the examples I've got in my code examples, but yeah, you build now basically all kinds of applications with this, just in JavaScript. Okay, so we've registered our service worker. That's it. You actually don't have to put anything in the service worker JavaScript file if you don't want to. The rules defined by Google and Chrome and Firefox and everybody else is that provided you've got a registered service worker, even if it doesn't do anything, your application still counts as a PWA, which means that it will trigger the installation pop-up for you, even if you're not doing anything with that service worker. But you probably do want to do something with the service worker because it's pointless otherwise. So let's have a look what goes in the service worker JavaScript file. So there is a global variable available in your service worker called self, which is just referring to the service worker itself. We add an event listener to it and listening for the install event, which is basically what happens when it registers the service worker against your application. Inside here, I've just done an event, a wait until, and then all I've done is opened a cache, opened a new cache using the new cache API, which is a new web API. And I have stored a my.css file. So I've just stored my CSS file in the cache. So the next time that I load a page, or if I refresh or anything like that, it's going to grab my CSS file out of the cache rather than having to go to the network to get it. That at the moment tends to happen by default in your browser, but this is just forcing it and say, right, this is definitely what I want to do. And you can do this to anything, so it doesn't have to be CSS. You can cache your JavaScript, don't cache your service worker. I've done that, and then you get into a world of hell. It's not good. Yeah, so you can cache anything. You can cache data, you can cache files, text, whatever. It's basically just a data dump place. We can improve this a little bit. So that was just putting something in the cache. Now I want to make sure that I get something, that I get it back out. So I've now done an event listener on fetch, which is basically AJAX requests. This does work on XML HTTP if you're not using the new fetch API. If you're using the old way or jQuery or whatever, it will pick up basically any network traffic. So this is listening for any network traffic and just saying, check whether it's in my cache. So cache.matches is the request that they're doing in the cache already. If it is, then respond with the thing from my cache, returns the cache file. Otherwise, actually perform the network request and go and get it from the server. Yeah? Okay, so this basically now we have control of all HTTP requests coming out of our application, and we can decide what to do with them, whether we're going to get something out of the cache or whether we're just going to cancel them, or what we actually want to do. This gives us a lot of power, and that's what we're going to talk about now. So an example of what you might want to do with this, say you've got a notification queue that only updates, or you only want to actually get notifications through to your application once every 5 minutes, then you can use your service worker to do that. Okay? So here I'm just storing the date on the fetch request, either storing the current date or storing the date from the previous request. And then I'm just doing a comparison that says, is the amount of time that's passed since the previous request and the current request more than 5 minutes? If it is, then go and get some new data. If it's not, just return the data you had last time. Yeah? So that if they're changing between pages, you don't have to go and re-get the same data that you've already got if you know that data is only going to update once every 5 minutes, and you can change that number to anything you want, half an hour, 24 hours, whatever you want. Just utilizing your cache in order to reduce the amount of network requests, save your server load. All of this code, by the way, does actually work, except for some stuff later, so it really is just as simple as a couple of lines like this. Okay, so basically what's happening here is you make an initial request to the API, store your data, and then display it. User does some kind of interaction, like maybe they refresh a page, and some kind of action that requires the same data. The service worker kicks in, picks up the fetch request, decides how to respond. Should I send them back the data that they had last time, or should I go and get some new data? Returns the data in what appears to the client UI like an HTTP response, and then you can update the UI with that data, whether that's new data or existing data. Yeah? Okay, so the problem with this bit, or the bit that we haven't really talked about yet, is where do you do the stores data bit? So we could put it in the cache. We could put it in the service worker cache. This is mostly used for caching static files, CSS, JavaScript files, that kind of stuff. It does work with JSON, so you could just chuck JSON at it and it will create a JSON file for you, but that's not ideal. The problem with that is that then you've just literally, it just creates files like almost like cookies on your machine. It's not all that quick to retrieve JSON from. So other options for client-side data storage is the local storage API. This is designed for client-side storage. Unfortunately, it is synchronous. It's not an asynchronous client-side storage, so it doesn't work with the service worker. So the only other option you've got is IndexedDB, which is an asynchronous client-side storage database, basically. It's basically a database in your browser that you can use to store JSON or any kind of data you want.
Can you store images, videos, or something like that?
It's literally just a string storage. It's
local storage as well?
Yeah, so both local storage and IndexedDB are basically the same thing. One's synchronous, the other one's asynchronous. Local storage is not quite as versatile, but it's a bit quicker because it doesn't do as much stuff.
Isn't that like, isn't it very similar to like Chrome apps? You know, like I think local storage was a part of the Chrome apps.
Yeah, I think you're right. I think that local storage, that is probably where local storage comes from. IndexedDB comes from Mozilla. They created it first in Firefox, but now that's rolled out across pretty much all browsers. Safari a little bit behind with it, but it's all in progress. So a lot of this stuff is not quite ready yet, but will be available in the next six to 12 months.
Like if I create an app, do I need to care that, let's say, Safari doesn't support these yet, and so on? So do I have migration problems between systems?
So you would at the moment, but as I say, some of these things are coming within the next 12 months. So IndexedDB is in the roadmap of things to be developed. So yes, there is some support issues at the moment, but the plan is that it will all be rolled out fairly soon. And the good thing about all of this is that, and you'll see more in the code examples, is that it's all just got fallbacks. So if IndexedDB doesn't exist and you can't put something in the cache, we'll just don't cache it and we'll just go to the network next time instead. It's not a problem. Yeah? Okay, so let's have a look at IndexedDB. What actually is it? So it's a client-side database, so database in your browser, if you like. It allows client-side storage of reasonably large amounts of data, at least for a JavaScript developer, it's a reasonable amount of data. Usually in JSON, but actually it just accepts strings, so you can kind of put anything inside it. It uses indexes, so it's actually really high performance, particularly for reads. It's a little bit slower for writes. Reads, depending on your CPU and various factors, but average you get about 1,000 reads per second, which, I mean, if you've got that much data being stored in your front end, then maybe start using your back end a bit more. But yeah, so it's not bad. Writes depends on the amount of data that you're writing to it, so there's no kind of available statistics for how fast that happens. It's an asynchronous promise-based API, so works with promises just like everything else does these days, ES6. And it's basically just a permanent data storage. So you just put something in there, and actually, as far as I can find, there's no expiration on that. It's not session-based, it's just, it'll never go away until you delete it yourself. I did quite a lot of research on that, and I couldn't find anything that said it would ever get deleted, so it looks like it's just permanent.
It's stored inside the browser?
Yes.
So you delete the browser, you delete the data?
I imagine it would probably go, yes. Yeah. Same kind of principle. If I deleted my database server, I'd probably lose my data.
Yeah, how often do you do that?
Even if you delete upcasting and stuff like that, it would still be there.
Sorry?
Even if you delete upcasting or anything like that, it would still be stored somewhere.
I mean, if you're using this, yes.
It doesn't have any access to any system.
Well, I mean, only what you communicate with via your JavaScript, really. So it's just a self-contained database that's just on the client side rather than on the server side. Okay. So using IndexedDB, it is a little bit more complicated than this, but this is kind of the basics of how to use it. This code won't work if you try and run this, but it nearly will. So connecting to the database, you actually have to kind of create a new database in order to connect to it. So IndexedDB exists in your browser already, and you basically say connect to a database called to-do list or whatever, and it will create it and allow you to connect to it. If it's already there, then it will just give you the connection to it. You give it your permission, so I want read and write. You could just take read if you only want to be able to read from an existing one. And then you do object store to-do list, which just is basically you have I haven't done a very good job with this, but this would be your database name, and this would be like your table name, so you can have multiple tables of data inside an individual database on the client side. Okay, so once you've got your database or your table, because I'm only using one for this example, I've stored it in IDB variable. Then you can just call add on it. You give it 2 arguments. The first one is the data you want to store. Oh, sorry. First one is the data you want to store. So I've just stored some simple JSON, and the second one is the key that you want to store it against. Okay, so I mentioned earlier how it's key based for quick searches. So I've stored it against a key of 1, which means then I can get it back out by doing .get, give it the key of 1, and I get my data back out. Yeah? To then update your data, So got my data back out. I've then done data.name, changed what my name was, and then I've put it back in over the top, idb.put, put my data in, specify the key that I want to override, and you've changed your data in the database. So if we go back and have a look at the code from earlier that we were talking about, the requests from after 5 minutes, we can now update this a little bit. If we assume that we've already got a database connection to our IndexedDB connection, then we can grab our response from our fetch request, call IndexedDB add, put our response in it, store it against a key. I've just used one. You can actually get it to auto-increment, but there's a lot of code involved in making it auto-increment, so I haven't given you an example of that. And then just return the response. Then later on we can just do, we'll just return IDB get the key of 1. Sorted. Yeah? Okay, this means now actually that you can do offline development. So now you can control your HTTP request, you can store data on the client side, and actually service workers have the ability to check whether a device is currently connected to the internet and then decide what to do if it's not. So you can say, right, if it's not connected, then let's get the data out of IndexedDB, for example, and just show them the previous version, and we'll just wait until it's connected. So we're going to go through that in a minute. Now, before we go into this stuff, it's really important to take into account your UX implications of doing this, okay? If you are going to start doing offline development, then please do 2 things. 1, tell your users when they're offline, because they might not know. Just show a little pop-up. Just say, right, you're offline. The data that you're viewing might not be the most recent data. If your application is showing the latest train times or current train times, they like to change quite quickly, as we all know. If they don't know they're offline, it's going to be a bit of a pain. So please update your UI. And please also consider whether actually offline development is right for your application. Should it work offline, or should you just show a thing and say, nope, you're offline, let's just wait until we're back online again and you can start using it. If you're doing financial statistics, for example, stocks and shares, what it was 10 minutes ago probably isn't relevant at all. They don't need to see that. Just be like, no, you're offline. Okay? That's not rendered very well. There's quite a bit of code in this bit, and some of it is quite advanced, so I've kind of tried to compress it down a little bit. So some of this code now doesn't work. Warning. Okay, so offline support. So we're coming back to our fetch handler from earlier. We've still got the same bit of code as we had before, so where we're checking the date, and we're doing the fetch request if it's less than 5 minutes ago, over 5 minutes ago. Otherwise, we want to retrieve the data from IndexedDB and return with it. So I'm going to talk about this bit, okay? So the bit that's actually going to the server now. This doesn't all fit in one slide, so I'm going to talk about this and just do it like that, okay? So here's my fetch request from my other screen, where I'm sending my fetch to the server to go and get some data. Now, if your device is not online, if you're not connected to the internet, your fetch request will throw an exception, okay? If there's no response, if it can't get a response or it can't get out to even get a response, then it will throw an exception. If it gets a 500 or any kind of error code back, then you won't get an exception, you'll get a valid response of that status code. But if it can't actually get out to the internet, then it will throw an exception which you can catch. This means the server's not reachable, you're not online, we can do something about that. So inside our catch statement, we can go to IndexedDB, get the data that we had before, and return it if we've got it. If we haven't got it, then we can just return a message. We can use the post message API that I mentioned earlier to pass a message back into our front end, our client UI, and just update the UI and say, nope, you're not online. I haven't got any cache data. Please wait until you're back online. Yeah? Okay. Then on the other side of things, on your client UI, on your actual front end, we can use this thing called navigator.online to check whether the device is actually active. The device is connected to your network. So you don't actually have to wait until a network request goes out in order to update your UI now. there are two events, online and offline, which fire on the window. So I've just added an event listener to online and offline, called a function called isOnline, which grabs an element from my DOM, hides it by default. If you're not online, it shows it, and that would just contain a message that says, you're not online, please wait. And that means that even if your application is not currently doing a network request, as soon as you go offline, you'll get that pop-up appear, or however you've CSS'd it, to say, you're not online, the data that you're seeing might be old. Yeah? Okay, so let's have a look at the workflow for this. So you make your initial request to the API, as before. The data that comes back gets stored in IndexedDB and displayed. Then the user performs a page action, like last time, like a refresh or something. The service worker will kick in. It will pick up that fetch request, and now it will fall back to IndexedDB if the network's down. So it will just return the data that it already had from the cache, and your client UI won't know any different as far as it's concerned. This is valid data that's coming back from a network request, and then you can update the DOM. No more code needed in the front end. So one of the other really great features about service workers and using PWAs is that they have this thing called background sync now. Okay, this gives us the ability to send a network request, send a fetch request, and if it's offline, rather than just sending back some stale data from your IndexedDB or whatever, like we were doing earlier, now you can just say, all right, you're offline. I'm just going to wait until the network comes back, and as soon as it comes back, I'm going to send that fetch request and go and get the data, and then come back and I'll update the API. Update the UI. So it can so what I'm doing here is I've got my button on the front end, so my app.js file, got a click event on it, and this is just using registration.sync register, which just registers a new background sync, which calls a function called, which triggers, it's like an event, if you like, called update trains, for my example. Then in my service worker, I'm listening for the sync event, and then hooking into the particular event that is update trains. And then I'm doing event.waitUntil, and then calling a function called update trains, which will just do a fetch request to go and get my new train data, or whatever it is that I'm getting. Now, if I'm not online, this event.waitUntil will just sit there, happily waiting until your application comes back online, and then update. So if you've got some kind of auto update on your front end of refreshing your train times every 30 seconds or whatever it is, and you go offline, it's not just going to keep queuing up all these network requests or keep responding with stale data from your IndexedDB. It's just going to send one and then go, yeah, I'm going to wait until my network comes back online, and then I'll go and make the request. Yes?
Can you stop that wait, like if they are offline for over 5 minutes and nothing's happened?
Cancel the sync. Yeah, so it's just a service worker event, so you can cancel the event in the same way that you would cancel any events, basically. Yeah, it's a good question. I haven't looked into it, but you can cancel events, but because the particular event for here is stored in the tag, I don't know whether you can cancel the event for just like that tag, or whether you would have to cancel all of your syncing events. I don't know, is the answer to that. Now, I haven't got enough space on my slides or enough mental capacity to make it work, but what you can do is put this stuff in with the IndexedDB stuff that we were doing earlier and say, right, well, go and get the data to start with, put it in IndexedDB so that we've got it for later, register my background sync, start the sync, so make the request. If you're offline, we'll wait until, register your fetch request, which will wait until the the device is back online, and whilst you're waiting, just return again with the IndexedDB data, and then as soon as this finishes, send the real data back, so that you don't just get this. If you've got some kind of like loading GIF when it's refreshing or something like that, you can actually say, right, we're just going to put the old data back up, update the UI to say you're offline, and then wait, and it will just seamlessly update the data in the background as soon as you come back online. I didn't have enough room to put all of that code though. Okay, so let's talk about some of the limitations, because I've been talking about how cool PWAs are, but what's bad about them. So the biggest drawback of this is that you have a limit in your offline storage, the amount of data that you can store offline. So iOS limits you to 50 megs. Android keep changing their mind. It was 6% of your hard drive a couple of days ago, and then it became 2 gigs, and then they upped it, and yeah, they can't make their mind up. But last time I checked, it was 2 gigabytes. Hopefully you're probably not storing that much data in, at least offline. But yeah, 50 megs from iOS. Question?
Is that per app or for all apps?
Yeah, per application. And that's across the entire application, so it's not just what you can put in IndexedDB, it's everything from all of your JavaScript, CSS, HTML that's downloaded, everything that you've registered in the service worker cache, anything that you put in IndexedDB, the whole thing cannot be bigger than those numbers. Okay. Most of these are iOS. So iOS automatically deletes your PWA if you don't use it for a while, obviously. So what it will do is it will look at, if you haven't been using the application for a couple of weeks, it will basically just free up space on the phone by just deleting anything that's in your cache. So it will just delete the everything in the cache and everything in your IndexedDB, and just say, we don't need that stuff anymore, it hasn't been used. But it won't get rid of the icon on your home screen. So as far as they're concerned, nothing's happened, as far as the user's concerned. Then when they click the icon again, it'll just try and re-download everything as if it never happened. It just means that after a couple of weeks, when you reopen the application, it'll be a little bit slower because it's got to re-download the stuff.
Does that mean that in iOS the permanent data isn't permanent?
Yeah, pretty much. Yeah.
The way you say it's actually nowhere. There's no place. The data can't be deleted because even the IndexedDB, it's the offline cache storage. It's the same as being in a browser in your Firefox, just delete the offline cache. It's not the cache. It's different, but it can be deleted. Even the IndexedDB.
Yeah. So you can delete the stuff in the your IndexedDB. Yeah.
Actually, we talked about it. Said you cannot delete it unless you delete the app.
Oh, sorry, no. So you can delete it yourself via the JavaScript. So the application. Oh, as in the user. Oh, I see. Yeah. So So if you clear your app's cache, then that would clear your IndexedDB stuff and anything stored in the app cache. Yeah. Or you can do, if you're on desktop, Chrome tools have got really great PWA support now, where you can go in and view all of the data in your IndexedDB and in your service worker cache, and you can delete it, update it, do whatever you want with it via the DevTools now as well. Sorry if that was unclear earlier. Yeah. So iOS auto deleting, not a massive problem, but not ideal. This is getting better, but at the moment, the difference between what you can do with a PWA and the web API, the mobile web API, and what's available to native app developers is quite big. It does vary between your between devices. So iOS has only just implemented service workers. It was about a month and a half ago. So this is very new in Apple. Android have had it for about 2 years. So their mobile web API is a little bit better. But on iOS, you don't have any access to native features like Bluetooth, the Touch ID thing, the fingerprint, the Face ID thing. You can't access any of that. None of the battery information. You can't use Apple Pay. Basically, any of the native features to the phone, you don't really have access to. On Android, some of these things are in development. Some of them are out in beta testing at the moment. Most of them don't. Google have kind of released a lot of these things, but they haven't decided that it's standardized yet. So you can use them, but they're subject to change. So existing ones on Android. So Android can actually do Bluetooth. You can look at the mobile connection, so the network. You can look at the Wi-Fi connection. You can actually control phone calls. You can control text messages. You can look at contact information. You can control sound and vibration now. You can look in the device storage. So you actually look in the files that are on the device. You can do push notifications. You can control the alarm. I could keep going for a while. you can do all of this stuff via the mobile web API at the moment on Android, but as I say, none of it's standardized, so be careful about using it.
What kind of permissions are there? So when you install an Android app, it tells you.
Exactly the same. Works in the same way, yeah. So it doesn't happen at the moment at the point of install. It happens at the point of it wanting access. So as soon as the app says, right, I want to make a phone call, or I want to intercept your phone call or something, then it would pop up and say, this app wants permission to do this thing. The big difference, which is across the board at the moment, is that there is no background work. So when the application is not open, it can't do anything, okay? Which is not the same as a native application. When native applications are not open, they can still do stuff. They can still receive notifications. You get, text messages, whatever. PWAs can't do that. There is in the pipeline some work coming from Google where they're looking at creating some background things that PWAs will be able to do, but that's not here yet, and don't rely on it yet because I don't know when it's coming. Yeah.
Who's policing those notifications that's trying to get access to the data? Is that the browser itself?
Sorry, I don't understand what you mean.
So you have the pop-ups to say, I want access to your pictures or something like that.
Yeah.
The app is looking for access to it.
Yep.
Is that the browser that's bringing up those?
Yeah. So it's the web API. So it's the browser interacting with the phone, because obviously the browser is a native application. So it, as a thing, has access to that stuff. It's just that from JavaScript you can't access that bit, or you can now, but you couldn't before access that bit of the browser. So yeah, it's effectively when the pop-ups come up, it will say at the moment, because it's still not standardized and not great. It won't say like the train app wants access. It'll say Google Chrome wants access to your photos or whatever it is, because it's actually the browser that's accessing those things. Hopefully that will change at some point to clarify it with the users, but at the moment, yeah, it just looks like the browser wants access.
Security risks with that?
Lots. Yeah. I mean,
it's like installing any other piece of software in your desktop.
Yeah, exactly. I mean, there's no more than if you're installing stuff through the App Store. The difference is that with the App Store, all of your code is checked by Google or Apple to make sure it's not malicious. PWAs, there's none of that, so it'll just install straight into your phone. Potentially, you click install, not realizing what the button does, and it just background installs, and then I'll just give it permissions to that thing. I don't know what it is, and I'll just background make some phone calls to premium rate numbers. Potentially all of that is possible. I don't know how that's going to work. There's talk at the moment of doing things like having authorized PWAs, which do appear in the App Store. Windows have got a PWA App Store. I don't know the URL off the top of my head, but on a Windows phone, you can go to a Microsoft App Store designed for PWAs, and they check the code. So potentially that'll be the way to go.
Just install anything on mobile, and it's completely different from your desktop. With payments and everything.
And that's part of the reason that the Apple and even Android, I guess, kind of haven't gone down all of those native things, because there's a lot of issues around, if we're not going to be policing the code, do we just want to give everybody immediate access to all of this stuff, which could potentially be quite dangerous? So yeah, there's definitely some questions around that. Okay, so what does this mean for you if you're a backend developer, or just for your application? First thing, probably brush up on your JavaScript. It's quite a bit of JavaScript there, particularly if you're just a PHP developer. But really, it will mean, or I'd like to think that it'll mean at some point, you can just, don't quote me on this, just fire all of your native app developers and just hire some more JavaScript developers and just start using this instead. Not yet, maybe. But most importantly, it means less HTTP requests to your backend. Yeah, less overhead in your application, faster applications, better user experience, and less service to have to deal with all of that data coming in and out. So a couple of resources. Serviceworker, servicework.rs is a Mozilla site which has got a bunch of examples of all the different kinds of things that you might want to do with service workers, and then they've got code samples, which kind of basically takes you through it step by step. It's not a tutorial; it literally just gives you the code of how to do it, and then takes you through it. There's all sorts of them. There's a menu down the left-hand side that will show you how to do all of it. None of them are more than about 30 lines of code, so it's a really nice, just very simple introduction. PWA stats. This is where all my stats from tonight came from. I actually don't know who. Oh, here you go. So Cloud4 have made this, and it's just a bunch of use cases or examples of people that have already done PWAs and the performance or the statistics that they're finding, the benefits of why they did it. And then most of these will link through to a blog post about that thing. Questions? Yes?
Is it in Apple's interest for this kind of stuff? Because presumably they make quite a bit of money through the App Store.
I wrote a blog about this a couple of weeks ago, as it happens. Off the top of my head, Google made, I can't remember which one it was. Google made £27 million in 2016, and Apple made 9 million, or maybe it was the other way around. I can't remember. So yeah, it's definitely, they make quite a lot of money from their app stores. So is it in their best interest? I don't know. No, probably not from that perspective. The idea of PWAs is not that it will just replace all native applications. It's that it will replace applications that users are going to a lot. So it's likely to replace things like your newsreader, maybe Facebook and your Twitter application, stuff that you're using sort of every day to speed it up. It's not likely to replace, the game that you play, like a couple of games, or I don't know, some of the things that are just that either need to be bulky or that can't be done as effectively in JavaScript, or anything that actually isn't already a web-based application. So Twitter, Facebook, all of that, they're already web-based applications. It doesn't make any sense for us at the moment why do we go to facebook.com on our phone and go, no, I'm not going to use that, I'm just going to install this application, which is at the moment 150 meg. Why are we doing that? We can just use it on the browser. The reason is because the browser experience is not as good. So this is trying to make the browser experience better. And that's where their use case comes from, in that it will save the amount of data that's being transferred, it will save the amount of data having to be stored on the phone, it makes a better user experience, and actually it's Google pushing all this stuff. Google just kind of like to be pioneers in their field and like to constantly be pushing technology, so I don't think they're too much thinking about the money and more just thinking about this is something cool that we should be doing. Yeah.
So I work in fintech. So presumably, based on all the conversation that we've had around security issues, PWAs won't be able to or shouldn't replace anything that requires having that kind of security, anything that involves your bank or your identity or like PayPal even. Because
yeah, I mean, I don't know a lot about the laws around what you can and can't store on or offline, but I definitely would not advise, as Dave said earlier, don't start storing passwords or any kind of sensitive data on the client side. You wouldn't have done it with cookies. Don't start doing it now. It's no different. Like you would just start opening yourself up. But if you've got data that's not sensitive, that's related to your application, which I'm sure you will have, because not everything is financial data. You'll have some user data that's not necessarily that's for them potentially. Then you could store that. Yeah.
What kind of build process, if any, is required for this? Because you were using a lot of ES6 there.
Yeah.
Obviously, Chrome out the box supports a lot of that ES6 anyway.
Yeah.
Is there any build process involved?
Okay, good question. So any browser which supports a service worker supports ES6, because ES6 came before them. So you can just straight away start using ES6, at least in the service worker part. In the bit of code where I registered the service worker earlier, I do a quick check to see if the service worker is valid, see if the service worker is supported in the browser. If it's not, then the rest of the code just doesn't matter. Anything that's not in the service worker file, so the actual registration, I probably would write that still in ES5, because that's still getting passed, even if it's not being actually run. Or you can use Babel, which is, if you don't know what Babel is, it'll convert your ES6 code into ES5 for you, so you put that in your, it's part of your build process. But if you've got a reasonably heavy JavaScript application that's running in your, then you're probably already doing that, so there's nothing more to do there. And you don't need to build anything actually in the service worker. There's no build process there, because it's just ES6.
All the user actions that happen offline, saving a holiday or whatever, how does that get synced back?
So the background sync stuff that I was talking about, so if the user is saving some data, I would do that with a background sync. So make the request. If you're not online, it will just wait. And what you can do is just, you can respond from that request and say, yeah, it's saved, even though you're offline. So it could come back and say, I mean, this is about the way that you treat your users in your UX, but maybe pop up a message saying you're offline, but we'll save it as soon as you come back online. And that background sync will then just sit there and wait until you come back online, at which point it will save, that holiday request. My advice is to just not do that with online payments. You don't want your online payment just sitting in the background waiting to go through. Dangerous. I just wouldn't do it. But otherwise, yeah, that's the way to use your background sync. Yep. One more? Okay, go on, Jack.
How does the service worker decide what out of your files on the client side needs updating? Obviously, the content you want to be updating constantly, or as soon as you can, but
like your cached CSS and stuff.
yeah.
So you would. There's a whole section of this talk that I didn't put in because it was going to take a really long time and it's quite complicated, to do with the way that registering service workers happens, because obviously the first time you visit an application you haven't got your service worker, it has to download and register it. Once it's then registered, that service worker is running in the background for every subsequent visit, and you'll cache the stuff on that first visit, so that then every subsequent visit you've got it cached. What you would do is, when you register the service worker, you provide a version number to it, and then when you update your CSS file, for example, push that to your server and also push a new version number to your registered service worker, and you have to unregister your previous version and register your new version. It won't do that for you, but that's basically how you do it. You just say, right, that service worker which had that file cached is now the old one. Here's my new one. Please recache this file because it will effectively dump the cache.
And that will be doing in the background as a sync, or
yeah. So just as soon as you push the update to your server, you update your files. The next time they load, it would just invalidate the previous service worker and register the new one and recache all the files.
So it'd be like when you reinstalled it for the first time.
So it wouldn't redo the homepage icon. It would just mean that page refresh would take a little bit longer.
So that will automatically create a pool for all clients connected to your systems?
Yes. So it will invalidate the service worker cache. So it would recache all of the things in the service worker, but it wouldn't invalidate the IndexedDB data because that's actually that's not related to service workers, so it'd still have access to that.
I have application registered with 20,000 customers, and I'm making the update of the CSS file, changing the version, and after a second I have pull requests from all clients which are connecting.
So it wouldn't. So if all your records or your data is stored in IndexedDB, which is one of the reasons I recommend doing that, it wouldn't refresh. It doesn't invalidate your IndexedDB storage. It will only invalidate your service worker cache. So in your service worker cache, you just want to store your static files. So that's no different than what would happen before. Without a service worker, it will just re-pull down. It will just, as if you'd cleared your cache, basically, re-pull down your static files, but the actual client-side stored data in IndexedDB, that doesn't get invalidated because IndexedDB is separate from your service worker, so that's not a problem. Okay, thank you.